Okay, we are continuing through this proof, and I'm gonna bleed over here so we can kind of keep looking at the same diagram. Okay, we got angle 1 congruent to angle 2, so we've got a side and an angle. We either need another angle, and we're looking at that angle up there and that angle there. We don't know anything about that. They look like they're congruent, but we can't say that for sure. They look like they could be right even, but we're not sure. We're not given anything about GH being perpendicular to AC or EF being perpendicular to AC. We don't have any kind of theorem about these two little segments having to be perpendicular for some reason to a diagonal of a parallelogram, right? So we don't know anything about that. So we can't get angle side angle, but we might be able to get side angle side. And remember, we were talking earlier about looking at those two segments as being part of the whole side of the parallelogram. We have opposite sides of the parallelogram. So again, I have to go back and employ segment addition postulate. I know this problem got kind of long on us, but we keep running into the segment addition postulate idea. Okay, so segment addition postulate again, we're going to have to use the fact that DC and AB are congruent. So I want to get them involved in a segment addition situation because I know that HB and ED are congruent. Okay. So let's go ahead and get HB and ED involved as well. So I get HB plus AH is equal to AB. And I got what do I want to do? ED, yeah, ED plus CE is equal to CD. This is by segment addition postulate. Okay. Now I may want to go back and do some letting. Okay. Now we're given HB is congruent to ED. Let's let HB equal ED equal X. Let HB equals X since they are congruent. So by definition of congruency, I can do that. So that means I can plug that back in there. While I'm doing that, let's go ahead and make another variable y for the other parts that are congruent, the whole segment themselves. But we actually haven't said that yet. We haven't said AB. We haven't said AB is congruent yet to DC. So we got to say that. They're congruent because they're opposite sides of a parallelogram. So I'm going to let y equal AB, which is also going to be equal to DC, right? Since they are congruent by definition of congruency, etc. Okay, so now let's plug it back into our equation up there. Okay, I'm going to plug all that stuff back in up here and see what we get. On the top equation, we're going to get by substitution. My reasoning is here is going to be by substitution. By substitution, if you want to write the reasoning at the beginning. Some of you like writing the reasoning at the beginning. That's fine as well. I, for some reason, like writing at the end. By substitution. Substitution. What would we have? The y goes in place of AB and CD, so y goes on the right, right? And let's put x in place of HB and ED, so x goes on the left. And what we're left with is plus AH in the middle on one, and plus CE in the middle on the other. Right? Does everybody agree with that? Okay. Now, by subtraction property on each equation, let me call this equation 1 and equation 2. Okay. If we do AH, if we subtract x on both sides, we get y minus x. AH, oh gosh. And CE also equals y minus x, subtraction property of equality. I don't know why I'm having so much trouble writing with this pen. Okay, so now what does that mean? Great, so now AH equals CE. By transitive property. Transitive property says when two things are equal to the same thing, they're equal to each other. Transitive property of equality. And so now that means AH, the segment, is congruent to CE, the segment, by definition of congruency. I haven't been too picky about that step, so don't worry if you don't get that step all the time. But now we actually have what we want to get these two triangles congruent, right? So now I can say triangle AHG, AHG is congruent to triangle CEF by side angle side. And our typical next step after that is using CP/CTC to get the things we want, right? We really want to get that other part, GH, congruent to EF. Okay, so GH is congruent to EF. Oop, straight line. By CP/CTC. It's a beautiful thing. CP/CTC. Congruent parts of congruent triangles are congruent. No. What is it? Not congruent parts, corresponding parts. Okay? Corresponding parts of congruent triangles are congruent. Corresponding parts. That means parts that match up. Those parts match up. GH matches up with EF. GH matches up with EF the way we wrote it. Okay? Okay, I'm hoping to see some more requests come in.